This is chapter 2-2. This is recording number 1. All right, folks, so where we are is in chapter 2. This is frequency distributions and graphs. We've talked about the frequency distributions. Now we're ready to talk about the graphs. Let me just spend a moment, though. I like to analyze the language because I think that many times people don't do that and they miss something. Remember, I mentioned to you before, the word frequency in this context means how many times. Distribution means how is it distributed? How is it spread out? So when we were talking about in section 2-1, when we're talking about the frequency distributions, you'll notice that we're always talking about how many times something happened, right? And we are asking ourselves, how is the data, how is the information, how is it spread out? So, here's one example. You have a certain class, and, you have a certain type of, this was a blood type. Type A, there was 5 of them. B, there were 7 of them. Type B, there were 7 of them. Type O, there was 9 of them, and so forth, okay? So it's how spread out is the information. And here's another example. We have the different class limits. So that's what the word distribution means, is how is it distributed among the various classes. And then frequency means how many. Now, the reason I'm mentioning this is because in a frequency distribution, we're talking about what has already occurred. We have already measured these soldiers, and we found out how much blood, what their blood type is. This one here, we're talking about a distribution of blood glucose in this example. So we've already measured it. It's already happened. That's a frequency distribution. We'll see in a later chapter, we talk about a probability distribution. There are many similarities. They look a lot alike, and we use the same language or the same word to mean similar concepts. The big difference between a frequency distribution and a probability distribution is the following. In a frequency distribution, something has already happened. We have already measured something. In a probability distribution, it hasn't happened yet. This is our best guess as to what's going to happen. So there's a big distinction there. Okay, so I want to move on now from the chapter 2.1. We're going to go into 2-2, and we're going to talk about various ways of graphing this. All of this in section 2-2, this is all aimed at, or it's the basic idea behind this is the same, and that is, how do we show this information in a way that is useful? Okay, so that's what we're talking about here. You want to present it in some sort of a graphical form. You want to convey the information in a what he's calling pictorial form. In other words, as a picture, okay? And the reason why is because for most human beings, it's easier to comprehend the information if it's in a graph of some sort, okay? All right, so the 3 most common ones, we have a histogram, the frequency polygon, and a cumulative frequency graph, otherwise known as an ogive. Okay, so here's always the rule. He always has in the blue tables, he has the algorithm. An algorithm is a step-by-step process. And what the heck is a histogram? A histogram is impossible that you've never seen a histogram. You've seen them somewhere, somehow. I guarantee it. Okay, just to take something right out of the headlines here, what I did was I Googled graph COVID deaths just to get some sort of a relevant statistic here that you can look at, and naturally bazillions of hits came up. I just grabbed this one at random. This is from NBC News. Okay, so here's a histogram right here. It goes by date along the x-axis. Along the y-axis is reported coronavirus deaths per day. So as you can see, we've graphed this data. Now the concept is, so I'll let you look at that for 1 second. Okay, the concept is very simple, and that is, here we go. Here's a whole bunch of ones. Okay, so here it is by states. So these are all histograms. And the idea behind this is that it's a lot easier to look at this and to get an idea of what's happening as opposed to trying to just look at a bunch of numbers. As human beings, it's easier for us to understand it, okay? I think that's about all I want to show you here. I'm just trying to illustrate to you that you've absolutely positively seen this before. Okay, so the first thing we want to talk about is a histogram. It's a graph that displays the data. We use contiguous vertical bars. Now, listen, you should, as long as you're in college and for the rest of your life, as far as I'm concerned, but as long as you're in college, you should always have a dictionary with you, okay? Because there is absolutely no way in the world that you're going to know the meaning of every single word that you hear in a class or on a lecture or whatever. I mean, for crying out loud, I'm almost 70 years old and I still carry a dictionary with me. So I think that it's a very prudent idea. I will do my best to give you definitions for words that I think perhaps you haven't seen before or that are a little bit unusual, but I can't do it I can't anticipate and I can't know every single word that you're going to need help with. So make sure that you have a dictionary with you. So contiguous. Do you know what contiguous means? Contiguous means they're next to each other. So a lot of times you'll say, well, the borders of United States and Mexico are contiguous. They're right next to each other. There's nothing in between. So you would say the borders between United States and Mexico are contiguous. However, the border between Canada and Mexico is not contiguous. So it just means right next to each other. So they're contiguous vertical bars, okay? And we just graph the information. So here's the data that we looked at before for high temperatures. Here's the frequency. You look at this, a little bit hard to kind of get your arms around it. Okay, so here's the algorithm. It's very, very straightforward. You just draw and label the X and Y axis. Okay, you represent the frequency on the Y axis. So how many of these do we have? How many times does it occur? That's the Y axis. And then the X axis is the class boundaries. Okay. All right, so hopefully you looked at that in your book. I don't think there's really anything I can add to it. I think it's pretty darn clear. The frequency polygon is another common example. All right, and we'll see here in just a minute. The frequency polygon, in my view, has a few disadvantages to it. The histogram is so simple. You know, the concept is so simple. You look at this, and between 104.5 109.5, how many occurrences do you have? Well, you just look up here and you can see how many occurrences you have. It's very, very easy to read. It makes sense. You just glance at it and you know exactly what's happening, okay? So 104.5 to 109.5, there's 8 occurrences. So here it is. Between here and here, there's 8 occurrences. It's very easy to read. The frequency polygon is a little different, and I don't like it as much. Okay, and let me explain why. Let's see here. We bounced around here a little bit. First of all, here's the definition. I'll let you read that for yourself. It's pretty straightforward, I think. I hope, anyway. Okay, you display the data. You connect points. Okay, well, what points are you connecting here? You're connecting the midpoints. So the midpoint, 99.5 to 104.5, that's your class, right? 104.5 to 109.5, that's your class. Well, what you do is you say, well, there's an infinite, these are temperatures, right? Yeah, these are temperatures. So there's an infinite possibilities. These are continuous variables. So there's an infinite number of guys that can be in any of these classes. Between 104.5 and 109.5, there's an infinite number, okay? Why don't we just take the average? Let's take the average to represent that class. Well, what's the average? The average is, for this class, 104.5 plus 99.5, added up, divided by 2, that gives you 102. Well, that's the midpoint, otherwise known as the arithmetic mean. That's the average. The average of 104.5 to 99.5 is this midpoint, the middle of that boundary, or that class, excuse me, the middle of that class. The midpoint is the biggest guy plus the smallest guy, add them up, divide by 2, boom, there it is. Okay. Similarly here, 104.5 plus 109.5. Add them up, divide by 2, it's 107. That's the midpoint. So what we're basically doing here is we're saying, well, I'm going to let the midpoint represent that particular class. Okay, so here's the midpoints. How often do you get this class? Well, again, it's the frequency is just how often does it happen, right? So now instead of before we had these little, we had these intervals here, these little rectangles that we use. Now we're going to use these midpoints. So here they are. So 102, 107, 112. You see where they came from? Right here. 102, 107, 112. Those are the midpoints. So we plot those points. Put a little dot there on each one of those. Okay. Now, that's the x-axis is, the midpoint. What's the y-axis? Again, it's the frequency. It's how often does it occur. So let's take for 107, it occurs 8 times. For 112, it was 18 times. So 107 is 8 times. There it is. 112, it's 18 times. Exactly like we have up here. So those are the points. So you plot those points on your graph paper, and then you draw a little line segment between the points. Okay. Now you could skip that, right? You don't have to draw the line segments. You could just have these points plotted, right? But then it wouldn't be a polygon, would it? A polygon is, is a geometric structure that has, that has poly means many, has many sides. Okay, so it's a polygon because there's a line segment from here to here, from here to here, from here to here, and the theory is that it helps you look at it, helps you view this and get something out of it. Okay, so the concept is really simple, right? What I don't like about it is it can be misleading, okay? People look at this and they say, okay, so 102, this is a data point. 107, here's a data point. So in between here, there's all these points. These points in between here and here, do they have any real meaning? The answer is no. There's no real meaning to these points in here. It's just a cartoon. It's a way of depicting the data. And I don't like that because, from a scientific point of view, you like to be able to say that if you have a curve, engineers would call this a curve. If you have a curve, you want to be able to say, hey, I know it, if I find this data point, like right here, let's say is 105, and I go up here and I find that, the corresponding y value. So here's my x value, and I go up here, I get the corresponding y value. I would like to be able to say that that has some meaning, but it doesn't have any meaning. It doesn't mean a thing because we don't have any data for that, right? All we have is class boundaries, and we have a frequency for the class boundaries. We don't know anything at all about between, like, let's take this 104.5 and 109.5. How many were there at exactly 105? So you don't know. How many were exactly 106? You don't know, right? All you know is that there were 8 in this class. But unfortunately, this frequency polygon would mislead you, and you'd say, okay, 105, boom, come up here, come across here, I have an answer. But you don't have an answer. So I don't like it. I don't like the frequency polygons. I think they can be misleading. Okay, all right, so that takes care of those two. At the end of my video, so let me stop now, and then we'll talk about the next one in the next video.